Hello everyone, and welcome to the first video on the data types and variables playlist. Just a reminder then before we start that in addition to this YouTube site, and please do subscribe so you're kept up to date with new videos which I will be posting on the site, there's also an accompanying website which is at cs-compendium.net, and that provides extra insight and information with regards to both the GCSE and the A-level computer science course. And I also have a Twitter account which you can find at Endium Comp, and there I will be tweeting and retweeting some of the hot topics to do with programming and computer science at this moment in time. So let's make a start then on data types, and we're going to start with a definition. And it's always been the case actually that if you do Google what is a data type, you will get some very complicated answers coming back which are not particularly helpful for you at this level of your studies in computer science, and as many different answers as you have query results. So I've given you a very simple definition, I hope, which is easier to remember, and we can safely say that a data type is simply data that shares common characteristics and shares a common set of rules. And if that means absolutely nothing to you at this moment in time, don't worry, because it will become a little bit clearer as the video progresses. So one of the things I did want to do in this video, which is something which I tend to avoid in most of the videos that I do, is to go off at a little bit of a tangent and to explain why a particular topic in computer science is important, and to understand why something is the way that it is. Because one of the characteristics of data types is that in an exam it's actually very easy to forget all about data types, because we don't actually address them all of the time when we do practical programming, and secondly because the topic feels a little bit abstract, it's not really rooted in anything, and we don't really understand why it is that data types are important. So I did want to take some time out to explain to you what is going on with data types, and hopefully that will help you to have the aha, now I get it moment, which will help you in an exam to tackle data type related questions. So in the next part of the video I will be taking that little bit of a tangent and talking to you about why data types are so very, very important in computer science and programming. So I'll see you in the next part of the video. Okay, so in the previous part of the video we came up with the definition of a data type, and we said that a data type is simply data that shares common characteristics and shares a set of common rules. Why is this important then, and why is it relevant to programming and computer science? Well, to help explain this, we're going to go right the way back to Key Stage 3, when you guys first understood the fact that computers only talk the language of zeros and ones. It's the only language that they understand. We call it binary, but actually it's a difficult concept for us to get our head around when we are so used to communicating with a computer in our own language, in our own terms. But the reality actually is a computer has no idea about anything else apart from collections of zeros and ones, which we call binary. That's the language of the computer. And just to exemplify this, it doesn't really matter what type, excuse me guys, it doesn't really matter what type of software app or software system that we are using on a computer, it's all zeros and ones. If you have a look at the screenshot of GTA 5, it is very much the case now that computers are so good at processing zeros and ones that actually you have to look twice at the screen to decide whether that's a photo of a real car in a real street scene, or whether it's a computer generating a very, very realistic view using computer graphics, and the computer graphics are simply zeros and ones. Extraordinary that a computer should be able to do that. Likewise with apps which are number crunching, again just zeros and ones, but we can do extraordinarily powerful things mathematically and in terms of analysis with data. And you can see an example there of complex number crunching and the representation of data in a 3D type of environment. And of course now we've advanced hugely with deep learning and AI and robotics to the point where we have quite realistic androids that we can communicate with almost as if they were human. And you may have seen this android on the TV. This is Sophie, who really has a very, very spooky ability to communicate in a very human type of way. Once again, the point that I'm making, guys, is that all of these different extraordinary applications of computing are simply the computer processing billions and billions of zeros and ones. So the fact that computers can do that is extraordinary, but we do have to actually work a little bit harder for a computer not just to be able to process data, but to understand the context of the data as well. And without that, it can actually run into some problems. So what I'm going to do is I'm going to take what is actually a very complicated topic and try to explain why the context and the meaning of data is as relevant as what you expect the computer to actually do with data as well. So let's have a look at this example on the left. Now, straight away, if you look on the left-hand side of the slide, you will see the symbol, the @ symbol, and you will know straight away examples where, as human beings, we use the @ symbol in everyday life. We would use the @ symbol in an email. If you're filling out a form on the website, for example, you might want to use the @ symbol as part of a password. And there may be other occasions where you want to use the @ symbol as part of text or using text. For whatever it is that you're using a computer for. The interesting thing, and you've probably seen this, spotted this already on the slide, is that the @ symbol is represented by a combination of zeros and ones, which is 0, 1 followed by 6 zeros, which is fine, and there's no problem with that at all. But we also have a situation, this is one of many situations in the computer where actually we need to provide additional context for what it is that we want the computer to do, because the number 51, which you will know straight away is very, very different context of data than the @ symbol, is also stored as 0, 1 followed by 6 zeros. The symbols that we recognize on the right hand side are numbers that we want to do maths with, and that's a very, very different usage of data and information than the @ symbol. So the @ symbol, we want to use that for doing text related stuff. Okay, the other representation of the 0, 1 and 6 zeros is specifically for doing maths, or the opportunity to do maths with real numbers. So what we need to do to help the computer with this is we need to provide some type of context for the data that we're asking the computer to manage and process. Now, it's part of a much bigger picture here, because there are other amazing things which go on inside the computer to enable it to be able to understand and work with different types of data. And in fact, you'll have more of an insight about that when you come to look at the CPU, or the central processing unit, which is part of the theory part of your course. And then you will see how a computer works to understand data and the context of data in a little bit more detail. So what we actually want to say to a computer, or we want the computer to be aware of, is the example of 0, 1 followed by 6 zeros on the left hand side is an example of where we might want to text, for example, or we want to use that particular representation of data in the context of texting or using text. Whereas the other representation of 0, 1 and 6 zeros is where we might want to use a pocket calculator, or you might be doing mental maths, or you might be using an app on your computer specifically to do maths. How does a computer know which one of these two contexts you are wanting it to work the data for? Okay, so what we want to be able to say to the computer is, on the left hand side with the @ symbol, we want to tell the computer that on this particular occasion, 0, 1 followed by 6 zeros needs to be managed as a text type of data for creating words, sentences, paragraphs, even passwords, emails and ciphers, or encrypted text. And we call that, as human beings, the @ symbol in our particular language. On the other side, on the flip side of the coin, we might want to say to the computer, actually on this occasion, your 0, 1 followed by 6 zeros needs to be managed by you as a number type of data, so that we can do maths with that number. And in our language, we call that the number 64, because we work with the decimal number system. Okay, two very, very different requirements for data, which the computer sees as essentially being the same, 0, 1 followed. Okay, so hopefully this part of the video would have helped you to understand why data types are important. We'll talk a little bit more about characteristics and rules a little bit later on, but hopefully understanding this idea that data types are actually about helping a computer to understand the context of data. Hopefully that will bring data types to life a little bit more for you during the course of the video. Okay, so let's home in on exactly what you need to know for your GCSE course and for your GCSE exams as well, if you get questions on data types. The most important thing to remember is that there are 5 data types that you need to be aware of and you need to be able to recognize for your exam. Why 5? Because these 5 data types are the data types that we need to essentially characterize or contextualize any type of data which we talked about in the previous part of the video. So these 5 data types give us the opportunity to contextualize virtually everything that we need to one degree or the other. All will become clear in the next few slides. So out of the 5 data types, there are 2 of those data types which are exclusively for working with numbers where we want to do maths. So these are the mathematical or number data types, and we have 2 data types to choose from. We have a data type which is exclusively for whole numbers, okay, numbers without a decimal component or a fractional component, and we call this the integer data type. And in fact, the word integer means the same thing in computer science as it does in maths: whole numbers without a fractional component. That basically means they don't have decimal points. So whenever you see a whole number without a decimal point, we would represent that or associate it with the integer data type in computer science. On the slide, you can see some very simple examples: -100, -32, 0, because of course, just like with the calculator, we have to recognize 0 as being a valid number for calculations. 1499 and 1010, those are all examples of integers. No decimal points to be seen anywhere with the integer data type. Now conversely, if we need to do maths with numbers that do have a decimal point, in other words, they have a fractional component, then we represent or associate those types of numbers for doing maths with the float or real data type. Okay, 2 different names for what is basically the same type of data type. Some people say it's the float data type, some people call it the real data type. Doesn't really matter, it's the same thing. So the float or real data type is for associating numbers that have a decimal point, and that actually is the only thing that you need to remember. If it's got a decimal point, it must be a float or a real data type. Okay, if it doesn't have a decimal point and we're doing maths with stuff, then it must be an integer data type. And in fact, if you are working with 0 and you're working with the float or real data type, then 0 is represented as 0.0. Even 0 has a decimal point in it if it is the float or the real data type. So out of our 5 data types, those are the 2 data types for basically doing maths with data. Okay, now conversely, and of course the previous slides hopefully, or previous part of the video, would have helped to have explained this in a little bit more detail and to give it a little bit more meaning. At the other end of the scale, we have 2 data types which are used for data where we are not doing maths. So this typically is where we are using data as text, or what you and I would call text. So 2 data types for symbols and characters that we want to use as text. Now, of course, that does include character representations of numbers. Okay, if that sounds a little bit confusing, the easiest way to think about this is when we have the numbers in somebody's address. So the house number, for example, 112 Acacia Avenue, there's numbers in there, but we're not using the numbers of the person's house address to do maths. We're not going to add up somebody's house number with somebody else's house number and come up with a different number. Okay, so we still need character text representations of numbers to be able to communicate, but we are not going to do maths in the context of numbers in text. Okay, so hopefully that alleviates any confusion between numbers we're doing maths with and numbers we need to represent as part of text. So that's sentences, words, paragraphs, passwords, that type of thing. And on the slide you can see some examples of the 2 data types that we use for text. The first one is called the char, or the character data type, and this is when we only have 1 character that we want to work with. Okay, 1 character. The reason for this traditionally is that if we're working with 1 character, we can keep the memory usage down to the bare minimum. We only need a byte to be able to represent 1 character of data, so it helps to manage memory. If we've got more, 2 or more characters, in other words, a collection of characters that make up a word, a sentence, a password, a paragraph, or whatever, then we would associate 2 or more characters with the string data type. Okay, so the string data type is for 2 or more characters, a collection of characters which essentially become text. And on the slide you can see some examples. Hello world, so an expression made up of 2 words with a space in between is a string data type. The number 123, which, like I mentioned earlier, could be somebody's house number. Okay, it could be a contact, or it could be somebody's extension number at work. If we're not going to do maths with that number, then we represent it as text and we call it the string data type, or we associate it with the string data type. And just to emphasize the example that we used earlier with the @ symbol, there you've got an example of the @ symbol which appears as somebody's email address. That is part of a string data type. Now that's 4 out of the 5 data types. That just leaves the quirky one. And the quirky one really is quite quirky. It's called the Boolean data type. Okay, and the Boolean data type is the only data type that has a capital letter. And in fact, I've managed not to actually include the word, but also I've put Boolean on that slide with a capital B. That's good. I thought for a minute I hadn't actually exemplified the point. Boolean is a data type with a capital B, and that's because it was named after the mathematician and computer scientist George Boole, who was an extraordinary man who actually created a branch of mathematics called Boolean mathematics, which computers also use as well. So without George Boole, we probably wouldn't have computers. But he hasn't had a great deal of recognition, except for the fact that this data type has been named after him with a capital B. Now, what makes the Boolean data type a little bit quirky is the fact that it's only used to store a state. Okay, so if you think, for example, of something either being true or false, you can see some examples on the slide actually. Something either being true or false, it can't be both true and false. It's either one or the other. And the Boolean data type is to store whether something is true or something is false, but not both. So it can't store both at the same time. And in fact, the Boolean data type can only store one of those 2 values. It can't store text, it can't store number. It can only store either true or false. And on the left hand side of the slide, you see there's an example where I've tried to bring this to life and give it a bit of meaning, and you will come to understand the Boolean data type as you do a bit more programming as well. But if you have a look on the left hand side of the slide, you can see it says 2 less than 10, or 2 is smaller than 10. Is that true? Is 2 smaller than 10? Yeah, of course it is. So we would evaluate that bit of mathematics as saying, yeah, it's true. And if we want to store whether an expression like that is true or false, we would use the Boolean data type to reflect that. So 2 is indeed less than 10. So we would store the evaluation of 2 less than 10 as true, and we would store that in the Boolean data type. Conversely, if you look at the example underneath, is 200 less than 23? No, that's false. So we would store the result of that expression, 200 less than 23. It's wrong. It's false. So we would store false in our Boolean data type. Okay, so it is quite unusual. The other thing to be aware of, and it's something again which you will recognize the importance of later on in your course, is that if you swap the words true and false for yes or no, we could also store whether something is yes or something is no as a version of true and false. We could also store a state where something is either on or it's off, like a switch, for example. And of course we can also store whether something is a 0 or a 1. So that gives you a little bit of a flavor there. If you think back earlier to the video where we said data is either represented as a 0 or 1, that might give you a flavor of just how very, very important the Boolean data type is. Okay, so there we have the five data types with examples that you need to know for your GCSE and for exams. So I thought what we would do is I'd give you a little quiz. So here it is up on the screen. What I'd like you to do is to have a go, pause the video, have a go at this, and then come back to the video when you've had a think and you've got some answers to the questions that you can see on the slide. So I'll see you a little bit later on in the video. Okay, so how did you get on with deciding what type of data type you would choose to represent these values of data? So let's have a look at question 1, and this gives me a chance to use my flashy drawing tool. So we have question 1, 12.345. It's being used as a number, and there's only one data type which we can use if a number has a decimal point, and that is the float or real data type. We can't use an integer because it's not a whole number, it has a decimal point. So the answer can only be the float or the real data type for question number 1. So this one here, we have the @ symbol. So this one should have been easy because we've been talking about @ as if it was the most important character on the planet since the beginning of the video. The @ character you would store as a char or character data type because there's only one character, and of course it's not a number. We're not using it for maths, so it is quite clearly the char or character data type that we would associate it with in a computer program. Okay, let's have a look at the next one. Well, this is an example of text. Okay, it's basically, excuse me, 2 words back to back, and we know exactly what that means. So it must be a string data type. We're not using any of those characters for maths. There's more than one character, so the only data type that we could associate with that expression hello world would be the string data type. Now it gets a little bit trickier here because I've had to put a little bit of context once again around a particular data item, okay, or particular value. So I've asked what 12 would be. What data type would you associate 12 if the context of 12 was in somebody's house address, 12 Acacia Avenue, for example? Well, because this 12 is not 12 we're going to do maths with, it's part of text, then this would be stored as and worked with as a string data type. Okay, so the answer to question 4 is a string data type. But of course I've had to give you a little bit excuse me guys, I've had to give you a little bit of extra background as to what I'm after by giving you an example of how we would use it, okay, in somebody's address, for example. So this one, question 5, true with a capital T. So that's got to be a Boolean data type. It's got to be one of the other. It's got a capital T for true. If it wasn't true, it would be false with a capital F. So that must be the Boolean data type. And I'm not giving you any other context to suggest that I might want to use true in some other guise. Okay, now it's not quite the same with question 6, where I have given you a bit of context. So I've asked you what false is. So when you first look at that, you think, oh, that's got to be a Boolean because it's the opposite of true. So it must be a Boolean data type. But I've given you a bit of extra context. What I've said is I want to use false in the context of a text. Okay, I want to be able to say false, exclamation mark, you are less than 18 years old. Now, if I was using false in the context of a larger item of text, then it's got to be a string data type, because the string data type is one of the two that we use to represent text. So in this particular context, false would be stored as a string data type. Okay, it's being used to communicate using text. Okay, now the last one is a number. It's 18. I've not given you any other context. Okay, so that must be an integer data type because it's being used as a number. We're going to do some maths maybe with 18. It doesn't have a decimal point, so it must be an integer data type, or we would represent it as an integer data type in a computer program. Now, some of these questions I put together deliberately because I wanted to make a point, which I'm going to show you in the next slide, because the ideal scenario would have been to have presented you with the same questions looking like this. Okay, so have a look at the way that I have now phrased the data to make it a little clearer what the context is for some of the more ambiguous items of data. So you can see here, I have put the @ symbol in quotes. Now you may know this already because you may have done a little bit of practice, or we may have come across this in the classroom. But in order to make it clear that I want to represent characters or collections of characters as the string data type or char data type, I could put quotes on either side of the item of data. Now in Python, you can use single quotes or double quotes as long as they're consistent. Doesn't really matter. But as soon as you see quotes, that is basically the programmer or somebody like me giving you a quiz, basically saying this is essentially a text or a char data type. I'm not going to use this example for maths. So straight away, if it's got quotes, you know it's going to be a char if it's a single character between the quotes. If it's more than one character between the quotes, it must be the string data type. So this one is a character data type. Okay, likewise, I've put hello world, which you could probably have guessed anyway, because it's basically two words back to back. But to clarify it, I've put quotes on either side of hello world. That indicates to you, but also to a computer program as well, that I want hello world to be represented as a string data type. Now, where it's even more useful here is with question 4. If you remember, if I just go back to the previous slide, I had to contextualize question 4 by saying, oh, it's 12, but actually, so you don't get confused and think it's a number, this is the context that I want to use the 12 in. It's part of somebody's address, in other words, text. So the way to make it clearer again is to put it in quotes. And as soon as I put the number 12 in quotes, okay, I'm basically saying, yeah, it looks like a number, but actually I want to use it as text. So it's not going to be a number data type in this. On this occasion, it's going to be a string data type because you've got more than 2 characters between the quotes. Okay. Now this one is going to be Boolean because it sits there on its own. There's no quotes, so I'm not using it as a string, so it must be an example of the Boolean data type where we can have true or false. Okay, now this one, I'm going to leave the box there. Compare question 5 and question 6. So false, straight away you'd think, oh, that's a Boolean. But because I put quotes on either end, I am insisting that it's actually part of a string data type. Okay, because I want to use false in terms of everyday communication. Okay, the spoken word, a sentence, a paragraph, whatever. Okay, I want to use false in that context, not as a Boolean data type. So question 6 is a string data type because it's got the quotes at either end. Okay, and lastly then, number 18. Okay, it's a whole number, so it's an integer data type, and in fact you know for sure because there's no quotes on either side to say I want to use 18 in text, so it must be being used for maths, so it must be an integer data type. Okay, so hopefully that makes sense, and hopefully you had a good stab and you got most, if not all of those correct. If not, guys, go back and check through the video, make sure you understand the context of data types and how we represent those as well, particularly using the quotes. Okay, so in the next part of the video, we're going to do a quick summary and a quick wrap up, and then I'm going to talk a little bit about why Python is slightly different in the way that you actually practically program using data types. So I will see you in the next part of the video. Okay, so in the previous part of the video, I flogged to death the idea that we could contextualize and distinguish between numbers being used for maths of a particular data type and numbers being used in the context of text and communication, in which case, if it's a single number, it will be a char. If it's a number with more than 2 symbols, then it will be a string data type. Okay, so I hope that was okay and fairly clear for you. There is something you need to be aware of when you come to do programming with Python, and that's the fact that even though you need to make sure you think about 5 data types for your theory and for your exam, when you come to actually do practical programming in Python, Python only has 4 data types. The one that's missing is the char data type, and the reason for that was because the guys that developed Python had a think, and they thought, actually, if the char data type is just for 1 character and the string data type is for more than 1 character, why don't we allow strings to store a single character as well as multiple characters? And if we do that, it basically means that the char data type in Python is redundant, and that's exactly what they did. So if you want to represent a single character in Python, that's a string data type, as well as more than 2 or more characters as well. Okay, so just bear that in mind. You won't be using the char data type in Python, but you still need to be aware of it and to recognize it for your exam as well. Okay, so let me just get rid of that redundant pink box on the screen. Okay, so we're at the back end of this video now, so let's do a quick summary of the key points from this video. The first one is a definition of the data type, and I tried to keep this as simple as possible for you. A data type is data that shares common characteristics and rules, and you've got a flavor and a sense of common characteristics. We have data types exclusively for doing maths and numbers. We have data types to represent text. In terms of rules, it is very much the case that if you have a number data type, you can't build a sentence out of a number data type. And likewise, if you are working with the string data type or the char data type, you can't do maths with text, okay, which makes perfect sense. And those are two very good examples of the rules associated with different data types. And a good one to remember is the Boolean, because it's very, very restricted. A rule with the Boolean data type is it can only represent one of two possible values, true and false. It can't represent anything else. So a rule of the Boolean data type is one of two values, either true or false, but nothing else. Okay, we said as well during the video that you need to be aware that for your course and for your exams, there are 5 data types that you need to be able to recognize and work with. Okay, so we have the integer, the float or real data type, the char or character data type, the string data type, and the Boolean with the capital B as well, that represents true or false. Okay, and we also talked about strings, okay, having quotes at either end, so that you could recognize when the programmer is specific about whether data, particularly numbers, needs to be represented in a text type of form, or it needs to be as a number, a float or a real or an integer data type form as well. So quotes instantly tell you that a data type is either a char or it's a string data type. Okay, and you can see an example of that with the number 12 on the screen. We've also just said that Python only has 4 data types, which is fine. You just need to remember that for your exam there are 5 data types, one of which is the char. And in Python specifically, the char data type is redundant because the string will also work with single characters as well as multiple characters. Okay, so that brings me to the end of this video. I hope you found it useful. I will see you in the next video, where we are going to be talking about the importance of variables and what variables actually are in programming languages like Python and in computer science in general. So I will see you in the next video.